Okay, let's work out one last example. Based on annual driving of 15,000 miles and a fuel efficiency of 20 miles per gallon, a car in the U.S. uses, on average, 750 gallons of gas a year. If annual automobile usage is normally distributed, and if 29.12% of cars in the U.S. uses less than 500 gallons per year, what is the standard deviation? Oh, this is fantastic. Okay, let's take a look at a random variable x, which describes gallons of gas used per year. Okay, fuel usage in a year. And we know that, we know what? We know that the mean of this random variable is 750. Okay, but we don't know the standard deviation. We do know this, that below 500 gallons lie 29.12% of cars. Okay? So if annual automobile usage is normally distributed, and if 29.12% of cars in the US use less than 500 gallons, what is the standard deviation of x? Okay? Well, this is great. Let's look this up. Okay? Here is our z distribution. We're going to convert this normal distribution into a standard normal distribution. We need to find the value z on this axis associated with 0.2912 in the lower tail. Okay? So if we do that, we can find this area right here in the table associated with 0.5 minus 0.2912. Okay? And if we go do that, we'll find that z is equal to negative 0.55. Okay? If we go down to the 0.5 row, the 0.05 column, we'll find an intersection that is 0.5 minus 0.2912. Okay? So now we have the z associated with this amount in the tail. So now we just got to solve backward and find sigma. That is, z is equal to x minus mu over sigma. We have the value of z. It's negative 0.55. Okay, that value of z is associated with this number on the x-axis, 500. We know the mean. It's 750. But we don't know the standard deviation. So we just multiply this over here and this over here. And if we do that, we should get that sigma is 454.55 gallons. Okay? So a random variable whose mean is 750 and whose standard deviation is 454, it will have a proportion of 0.2912 that lies below 500 gallons.